Hi, I'm Arshia, and this is my Lab 1 presentation. This lab was collecting data on real-world constant movement using Tracker, and then coding the predicted movement of the object with GlowScript. So the parts of this lab were first recording a one-dimensional constant movement. In my case, it was the movement of a metal car along a track. Then I uploaded the video into Tracker and used Tracker to extract the positions of the car along the x-axis over intervals of time. And I had it also calculate the average velocity of the x component. Then I used the initial x position and the initial average velocity in terms of x to then create a computational model in GlowScript that would predict the position of the car at those same intervals of time. Then once I had those results from GlowScript, I graphed and then compared the expected, so from GlowScript, and actual from Tracker positions of the car. And the key topic of this lab was Newton's second law. So Newton's second law is the fundamental principle. In this case, I use the equation r final, or position final, equals r initial, the initial position, plus the velocity times the change in time. But the velocity in this case was constant, because when the net force on a system is 0, the velocity stays constant, which means, famously, that an object at rest stays at rest, and an object in motion stays in motion with the same velocity, meaning 0 acceleration. And what this means for me is that the car's motion, which no forces were really interfering with in the x direction, we assume minimal friction, the car's motion would have constant velocity. So again, we started off the car, me and my group, by pushing it, but I only started the video and tracking the position after the car was moving at almost like the same speed. It had stopped accelerating. I aligned the x-axis like this in Tracker and calculated the positions over the constant time intervals. The system in this case was the car, the surroundings was everything else, so the track, the table, the air, etc. The initial force was the push, but again, that wasn't a force acting on the car at the time of the video. During the video that I recorded, the only notable forces were really gravity and normal force, which would balance each other out, and then friction, which again I assumed to be very minimal, and I observed to be very minimal. And as you can see here on the very right, I have the time intervals in seconds, these are constant, and then the x position in meters, and then the velocity as well, the average velocity. I use this initial x position and this initial velocity, and I plugged it into GlowScript. And then I added iterations for a delta t, the same one as the one in Tracker. And notably, I applied the momentum principle by keeping the velocity the same, but changing the position to the position plus velocity times delta t, based on the equation I showed earlier. And of course, advancing the clock as well. So because of this, the velocity stays constant, and the position changes linearly. As you can see here, the predicted position in GlowScript and the predicted position in Tracker were very close. So although they were very close, there was a little bit of difference, and those errors were probably because of friction, because however negligible it was present. It was also because I did not include mass in my calculations. I kept it at 1 kilogram, and the fact that the entire model is very simplistic. But overall, my results were very accurate. The system and the surroundings themselves are very controlled, and I also controlled the error by keeping the time interval that I was working with very short. If I had switched the x-axis, so if I had just made the negative x-axis the positive x-axis and vice versa, then I would have gotten very similar results. The speed would be the same. The only difference was the velocity would technically become negative because I'm flipping it almost. But I still would have been able to generate like a correct model and gotten these very close, accurate results. Now, just because I was able to predict the motion and know that the net force is approximately 0 doesn't mean that I can know exactly how many pushes and pulls are happening at a time. I mean, I mentioned earlier that it's probably gravity and normal force are probably like those balanced forces acting in the y direction, not the x direction, but I don't technically know whether there were any other forces acting in the x direction, all I know is that they were balanced because the net force was appearing to be zero. Because, based on Newton's law, the fact that the velocity wasn't changing means that the net force is zero. It means that there's no other force interacting with my car to make it stop moving in a constant velocity, if that makes sense. Thank you.